So we will see what is alum. Okay, so alum is added to the water to remove the dissolved solid in the water. What alum does is it settles down all the solids that is present in the water or remove the alkalinity that is present in the water. Okay, just basic, you have to know the equation. What is the equation of alum when it is dissolved in the alkaline water? Okay, because it will help you to solve the any numericals. This is the basic, then we will move directly toward the numericals part. Okay, so this is the equation. You should remember this, otherwise you will not able to solve any problem. So this is the equation, and it is also necessary to balance this equation. It is 2 here. Okay, it is 2 here, it is 6, it is 18. You can see here 18. I have right. So here 18, so 18. Here is carbon. See how much carbon is 2 into 6, and 2 into 3 is 6, and then 3 calcium, and 2 aluminum. Okay, this is the balance equation. Now we will directly move to the question numerical that I have asked in the last years. So this is the very basic question that we will go through. So what question says is that determine the quantity of alum required in order to treat 12 million liter of water per day at a treatment plant where 14 ppm of alum dose is required. Also determine the amount of carbon dioxide gas which will release per liter of water treated. Okay, so we have this equation. So first question is saying that we have a total 12 million liter per day of water, and we have to, and it is asking that how much amount of alum required. Okay, and alum dose is also given. So dose of alum is equals to 14 ppm. ppm is nothing but milligram per liter. Okay, so you should understand what this dose means. Okay, so dose means in every 1 liter of wastewater you have to add 14 milligram of alum. Okay, so now first question is asking that for the 12 million liter of water per day how much alum is required. So you can use the simple unitary method. So for 1 liter of water it requires 14 milligram. So for 12 million liter, million means 10 to the power 6 liter of water required. 14 into 12 into 6 milligram of alum. So for per day, simply divided by per day. So for per day this total amount of water is required. So first part is over. Move to the second part. What it is asking, that also determine the amount of carbon gas will released per liter of water treated. Okay, so for per liter of water we are asking, not we have to ask for the 12 million, just for per liter. So we know this equation. Okay, so from this equation what we are getting, this is from we can say 1 mole of alum. Mole is nothing but molecule. Here only one, there is no coefficient here, so 1 to 3 coefficient, so 3 moles. 3 coefficient 3 moles, 2 coefficient 2 moles, 6 moles, 18 moles. So this is it. So 1 mole of alum produces how much carbon dioxide? 3 moles. 3 moles or molecule you can say. Okay, so we have to find it in per amount. So milligram per liter, final answer will be in milligram per liter. Okay, so 1 mole is equals to 1. And now in 1 mole how much gram? So calculate. So I'm not calculating each part, so just I'm saying how to calculate this. So for aluminum we know its weight is 27 and it is 2, so 2 plus sulfur is 32, sulfur is 32, then oxygen is 16 into 4, just like that you have to calculate, and you will get that final 666 gram. So we can say in 1 mole total 666 gram of alum produces 6 mole, or in this 12 carbon and 16 into 2. No need to worry, the weight of the weight of the carbon, oxygen, nitrogen, these all will be given in the question. So if you calculate this, then you will get the 12 and 3 into 6. So total it this much gram of carbon dioxide. Okay, so but we are looking at what we have to find. That question is asking the amount of carbon gas will be released or produced per liter. So in per liter, how much alum is dose we have given. So in 1 liter total alum is 14 ml, 14 milligram of alum. So we have to find in 14 milligram of alum how much is this. So in 6 gram of alum, this amount of carbon is produced. So for it in simple method, so just solve it. So unit method, we will put that in the downward this gram, and it is also in gram. So gram and gram cancel and multiply it by 14 milligram. So this answer but just, or it is what in per liter. So this answer will give you the x milligram of carbon produced. Okay, hope you understand the question.